RDS is a managed relational database service that is simple to deploy, easy to scale, reliable, and cost-effective. We support a wide variety of database engines, including MySQL, MariaDB, Microsoft's SQL Server, and PostgreSQL. The service has built-in high availability, the database engines are pre-tuned for performance, and it is a managed service, meaning that you don't need to worry about host or database engine level configuration. So it is, again, fully managed, meaning that the host and operating system level configuration is handled for you by Alibaba Cloud, and it comes with fully managed storage as well. You don't need to worry about how the database storage tier works. That's handled by us. Databases support up to 20,000 IOPS and 2 terabytes of storage for each RDS instance that you create, and you can upgrade memory and disk space according to your needs. And again, as a managed service, this is grab and go. There's built-in operations, backup, monitoring, and security tools, and of course, availability in the 3-node HA version of the service reaches up to 99.99% with automatic failover. So there are some trade-offs here. If you're building your own database the traditional way, you have to prepare the hardware, install the OS, install your database software, configure the database software, and then do performance tuning and tweaking. That can take 3 to 5 hours. Actually, I think that's an optimistic estimate. This is probably 1 to 2 days worth of work. On the other hand, if you're using Alibaba Cloud's RDS, you can have a database up and running in just 10 or 15 minutes. You choose your engine, you choose your database instance specification, which is how much memory, how many CPU cores, and how much storage you want, and then that's it. The database is ready to run. The only reason you would choose a traditional database is if you have some very specific, unique need for a particular feature that maybe we don't support or that maybe is new, or you're using a database engine that won't run on top of the RDS service. Otherwise, RDS is a solid choice. RDS, like our other services, runs on top of Apsara. It runs on top of the Apsara platform, and it depends on Apsara services like the distributed file system, Pangu, in order to run properly. Unlike ECS, RDS is a PaaS service, meaning that in addition to servers, storage, networking, and virtualization, Alibaba Cloud also manages the operating system, middleware, and database runtime. So you only need to worry about setting up databases and creating database users. That's it. You don't have to worry about actually tuning MySQL or PostgreSQL or patching or updating your operating system. That's all handled for you by us. So again, just to compare infrastructure as a service and platform as a service, you can see that with ECS, the operating system is also your responsibility. You have to make sure that it's patched and updated and working properly. But for RDS, you really only need to worry about the data and application layer at the very top of the stack there in blue. The architecture for RDS is fairly complex. Essentially, we have a suite of security services sitting in front of a cluster of RDS database nodes. Those database nodes are accessible on the common ports that you would normally use to access a relational database. So for instance, for MySQL, that would be port 3306. Those database nodes are then connected to our high availability control system, which checks for failures, and our backup system, online migration systems to handle failures, and task schedulers and monitoring systems as well. Of course, all of this is transparent to you as the user. And that's all for this section. In the next section, we'll take a look at different RDS instance types. We next turn our attention to RDS instances. So an RDS instance is a database service running in a virtual computing environment. So essentially, it's a virtual machine that is running a database engine for you. A user can decide the database engine, CPU, memory, storage, and network capabilities of the RDS instance. RDS provides a wide selection of instance types that are optimized to fit different use cases. Instance types comprise varying combinations of CPU, memory, storage, and network capacity. So how do you choose an RDS instance type? So essentially, we divide our instances into 3 series, and this is independent of the actual instance hardware. This has to do with how many active database nodes are running. Essentially, we divide our instances up into different types or series based on the level of HA or high availability service that they provide. So the basic edition has decoupled storage and compute with a single computing node. So if that node fails, the database fails. This is not high availability, there's only a single node, but The Basic Edition offers very high cost effectiveness because there's only a single compute node, so your costs are low. The High Availability Edition is a classic HA architecture with one master node and one slave node, with SSD storage providing better performance. The HA Edition is what we recommend for most production applications. And then there's the Enterprise Edition. This has one master node and two slave nodes. It's a 3-node system. This offers our highest reliability and availability guarantee, and it offers strong data consistency by synchronizing logs between these 3 database instances. This is something you would use for financial level or supercritical production applications. And then we also have a special edition for Microsoft SQL Server 2017 called Cluster Edition, which uses the always-on SQL Server functionality to provide HA. We won't talk about that edition more because it only applies to SQL Server 2017. So let's look at the critical difference between Basic and HA. So Basic Edition contains only a single node with no slave node for fault recovery. As a result, it's half the price of High Availability Edition, so it's a great choice for low-cost deployments or for testing and development deployments. The High Availability Edition has 2 instances in the same or different zones with automatic data synchronization and automatic failover. In the HA and Enterprise Editions, if one of the nodes fails, if the master node fails, one of the slaves can immediately take over and become the new master. I should point out that in Basic Edition, you can still recover from a failure, it's just not automatic. You would have to create a new temporary database instance and restore from a previous backup. Whereas with HA, if the master node fails, the system can fail over to one of the slave nodes in near real time. So just to recap on the editions here, Basic Edition has a single node. This is a good choice for small websites or development and testing environments. High Availability Edition has 2 nodes. This is a good choice for production databases at medium or large scale enterprises. And then Enterprise Edition uses a 3-node architecture. This is what you want to use for core databases with extremely high data security requirements. So this would be something in financial securities, insurance, banking, etc. This is for scenarios where you really cannot tolerate a failure at all. Instance types, there are essentially 2. There's what we call the common instance. This is our most cost-effective instance. A great advantage of this type is that storage capacity is not linked in any way with the rest of the hardware configuration, so you have a lot of flexibility, but you are sharing hardware with other users. So there's the potential for another user's database throughput or high CPU usage to have an impact on you, although this is not common. Then there's the dedicated instance or dedicated host. In this case, you have fully dedicated CPU cores with threads that are assigned to you and I/O capacity that's assigned to you, so that even if another user is using a lot of resources on the machine, your ability to use the resources allocated to you is guaranteed. This also has what we call reserved storage space for higher stability. So typically we recommend the dedicated instance because of the dedicated CPU memory and storage that you're guaranteed. And I should point out both of these are shared OS scenarios. You may not be the only tenant on the hardware. The difference is that with the dedicated instance, you have guaranteed performance. In the next section, we'll take a look at some of RDS's features. Let's now look at some of RDS's key features. We'll start with backup. So RDS offers automatic backup, meaning you can create a backup policy and adjust the timing of RDS data and log backups. You can see an example of that on the right. In the backup cycle configuration for an RDS instance, you can say how long the backup should be retained, how often they should be made, and at what time of day, and you can enable or disable log backup. So you can retain logs in addition to the actual database data itself. Automatic backup currently supports physical backup. We also offer manual backups, which allow you to make a backup of your RDS data at any time. Manual backup supports both physical and logical backup. In terms of cost, we have a formula for calculating how much database backup space to give you, and below a certain threshold, backups are free. So if you've purchased an RDS instance that has 20 gigabytes of space allocated to it, you can make up to 10 gigabytes of backups for free. If you have a 100 gigabyte RDS instance, you can make up to 50 gigabytes worth of backup for free. So keep that in mind. Once you exceed that threshold, which is 1/2 the size of your purchased storage capacity, then we do start charging you for backups. Also, you can obtain a link, a temporary link, to any of your manual or automatic backups as needed. So this way you can download an offline copy of your instance's backup file, which you can use for offline analysis or repair, or for importing into a different database somewhere else. If you'd like to keep your database backups long-term, but are looking for a cost-efficient way to do it, our storage module does support dumping your backup files into OSS, so you can keep them in OSS archive storage, which provides very cost-efficient offline long-term storage. Data recovery, I won't go into a lot of detail here. Data recovery is fairly complex. There are many ways to do data recovery for an RDS instance. If you've accidentally deleted a database or table, or if your RDS instance has failed, you can recover from any of your manual or automatic backups. The links in blue here explain different ways that you can achieve that for different backup and restore scenarios. Of course, if you're watching the video, you won't be able to click on the links, but if you search for the terms in blue, if you perform a Google search or a search within our documentation page, you should be able to find these relevant articles. And most of the examples are for MySQL, but of course, backup and restore is supported just as well for our other engines like Microsoft SQL. If you need multi-region disaster recovery, that's also achievable. So let's say you want to have live or near real-time failover between Shanghai and Beijing. Of course, the RDS service, just like ECS, is a region service. It's a regional service, meaning that an RDS database can't migrate from one region to another, but you can run two RDS instances in two different regions and sync data between them using our DTS or data transmission service as shown here on the slide. So this is an option for high-speed, high-reliability, multi-region failover. You can run two live databases simultaneously. Let's say one is in Beijing and one is in Shanghai. If the database in Beijing fails, you can fail over to Shanghai with little to no data loss, and that's made possible because DTS will synchronize data from the Beijing database to the Shanghai database and vice versa. It has a data subscription mode which will track changes to each database and then update the other database with those changes. Another helpful feature of RDS, which is currently limited to MySQL, is read-only instances. So you can add one or more read-only instances to your RDS MySQL deployment, and this can take read pressure off of your primary or master instance. This is great if you have a spike in traffic or your site suddenly increases in popularity and you start having a lot of database read requests come in. The read-only databases can take that pressure off of the primary or master instance. I should point out, though, that you can't use read-only instances to achieve HA. They're not for high availability. They cannot be promoted to a master. If you want to have high availability, you need to purchase the HA version of the RDS service. Another neat feature of the read-only instances for MySQL is that there's built-in read-write splitting. So we provide a database connection endpoint that automatically performs read-write splitting, meaning your application doesn't even have to know that there are read-only instances that can be transparently handled by RDS. RDS storage can also be extended in several different ways. You can add a cache layer. We have managed Memcache and Redis services which you can use to get higher QPS than you could manage with RDS alone. These provide high performance responses to database queries for commonly accessed data. You can also offload large database items, like say user photographs from an online forum, and store them in OSS to take pressure off of your RDS instance. So large items in your database could potentially be moved to another service like OSS. Next, let's take a look at monitoring and security. Next, let's look at RDS monitoring and security. The RDS console provides full performance metrics which allow you to get a clear picture of the running state of each of your RDS database instances. So these metrics are provided by Cloud Monitor. Cloud Monitor is the free monitoring tool that's built into the Alibaba Cloud platform. We also use this to monitor other services like ECS. And for RDS, Cloud Monitor can record storage usage, memory usage, so that's RAM utilization, CPU usage, and many more. Security. RDS provides a 3-level security defense system to protect databases against a variety of security threats. We have a built-in anti-DDoS service which protects against DDoS attacks up to 5 gigabits per second, built-in IP whitelisting which supports up to 1,000 IPs per whitelist, and WAF, or Web Application Firewall, which can help defend against brute force attacks, SQL injection attacks, and a few other forms of common database-level attacks. The RDS service also includes SQL audit capabilities, so you can keep track of the who, what, and when of database access and modification. On the security front, in terms of access to the RDS service and ability to manage the RDS service, we use something called RAM, Resource Access Management. This is actually how permissions are managed across all Alibaba Cloud services. So of course, under your Alibaba Cloud account, you may have multiple users. Perhaps you have developers and database administrators and auditors, and perhaps a few other types of roles. Each of these people will have their own RAM account, and they'll use this RAM account to log into the Alibaba Cloud console. RDS allows you to set what's called RAM policy, which controls which of these RAM users can access and manage RDS. Now that's at the RDS service level. So what do you do about database users? How can your DBA manage permissions? RAM can't do that. RAM is designed to manage access to Alibaba Cloud's services. So it actually works at the service level. If you need a service that allows you to manage user permissions at the database or table level, then you need to use DMS. DMS is our data management service. So with DMS, you can have a unified platform within the Alibaba Cloud console that manages access to individual databases, tables, and even columns for a variety of different users, and this is semi-automated. So as the database administrator, you can set up a web form where your RAM users can apply for time-limited permissions to use the database, and then you as the DBA can approve. When you approve, the DMS system will automatically generate and execute grant statements to give the user the permissions they asked for, and when their permissions expire, the accompanying revoke statements will also be automatically executed by DMS. So if you have multiple database users, this can save your database administrator a lot of time. Access control, so again, this is done mostly through IP address whitelisting. Every RDS instance has at least one whitelist, which contains the IP addresses or address ranges that are allowed to access the database. We also provide SSL encryption. In particular, this supports MySQL and I believe also Microsoft SQL. So you can include encryption in transit between your ECS instances and your RDS database. So if you want, you can add HTTPS SSL encryption as an optional feature so that access to your database instance is encrypted. So I'm here on the Alibaba Cloud homepage. Let's navigate over to the console and set ourselves up a new RDS instance. So I'll click on console here in the upper right. That will take me over to the console homepage. From the homepage, I can navigate over to RDS. I'll do that by mousing over this orange and white button here in the upper left, and then mousing over products and services. From here, I can enter keywords to perform a keyword search. I'll type in RDS. And then here's AppsaraDB for RDS, which is Alibaba Cloud's database service. So we'll navigate over to the database console, and I need to choose a region. I will choose Singapore, and then we'll create a new database here in the Singapore region. To do that, I go up to the upper right-hand corner, and I click on Create Instance. I can choose one of two billing methods here, subscription or pay-as-you-go. Typically, if you choose subscription, prices will be lower than pay-as-you-go. So if you were to compare the overall price for running a pay-as-you-go instance for a week or a month versus a subscription instance, then subscriptions are cheaper. But since I'm doing a demo and I want to be able to delete this instance afterwards, I'm still going to pick pay-as-you-go. Now you can see here you can choose from any of these four database engines, MySQL, Microsoft SQL Server, PostgreSQL, or MariaDB. And for each of them, we offer multiple different versions. I'm going to choose MySQL 5.7, and I can choose either Basic, High Availability, or Enterprise. And again, that's in either a 1, 2, or 3 node deployment. In my case, I will stick to Basic. You'll notice that for the High Availability and Enterprise classes, I sometimes have more storage options here. So for instance, eSSD PL3 is very, very fast solid state enhanced storage. But for basic, we only have standard SSD in Singapore, so that's what I'll choose. I can choose any of the 3 zones in Singapore in which to deploy my instance. I'll go with zone A. And then I have to choose a CPU core and memory configuration. So you can see I could do anything from a micro 1, which is 1 CPU core and 1 gigabyte of RAM, up to a X large 1, which is 8 CPU cores and 32 gigabytes of RAM. I'll go with a micro 1. And then again, compute and storage are decoupled for the basic instance, so I can choose storage for my micro 1 instance just by sliding this slider bar here. I can have up to 6 terabytes for a basic instance right now. I'm going to actually just stick with 20 gigabytes, that is enough. I'll then click next to go to instance configuration. I have to choose a VPC group and vSwitch to attach to. I'll do that here at the top. Then I need to choose a parameter template for my MySQL InnoDB database engine. I'll stick with this high performance defaults template. I have to choose a time zone. I'm in China, so I'll stick with UTC +8. And I can choose whether table names are case sensitive or not. The default is case insensitive, so we will leave that default setting. And then if I want, I can move my instance to a resource group so that it can be managed and accessed as part of a set of resources that might include some load balancers and ECS and whatnot. I will leave that at the default setting. And down here at the very bottom, I can check all of the configuration settings that I have chosen on the last few pages. Again, we're MySQL version 5.7, Singapore Zone A, basic instance type, attached to our Singapore VPC with one CPU core and 1 gigabyte of RAM, which supports a maximum of 2,000 concurrent database connections. That should be plenty for this demo. So I'll click next and go to confirm order. From here, I just need to double check my settings once again, agree to the terms of service, say how many ECS instances I would like to purchase. I just want 1, and then I'll choose Pay Now. And that should purchase my RDS instance and start the setup process. So it may take a few minutes for the instance to start. We can now close this tab, refresh the database list here, and in a few moments, we should see our new instance is in the creating state. So let's wait for that to finish. After a few minutes, the RDS database is up and running and ready to use. All I need to do to manage the database is either click on Manage here or click on the instance ID, which will take me to the database's home page, where I can see its region and zone, configure a whitelist for its internal endpoint, apply for a public internet endpoint if I would like one, see the database's port number, make changes to the billing settings for the instance, release it if I'd like, change its specifications so that I can upgrade or downgrade it, and create accounts and databases. So let's now try a demo. So we'll create a new RDS instance, we'll create an account on that instance, a database on that instance, and a table. We'll upload some data into the table, and then we'll make a backup. Afterwards, we'll try deleting the table, and then we'll try to restore the table from our backup. So to do all this, I'm going to start from the AlibabaCloud.com homepage, and the first thing I want to do is navigate over to the console by clicking on the console button in the upper right-hand corner. That will take me to the console homepage. From the console homepage, I can mouse over this orange and white button here in the upper left, mouse over products and services, and then I can either search for RDS or just pick RDS from the recent visits at the top, since I've used this product recently. That will take me over to the RDS console. And you can see currently I'm in the Singapore region, and I have no database instances running. So let's go ahead and create one. So I'll click on Create Instance. That will take me over to the instance creation page, the purchase page. And I have two options for my billing method. I can choose either subscription or pay-as-you-go. I'm going to choose pay-as-you-go. This is because I will be deleting my instance when I'm done with the test. If I were to choose subscription, I'd have to keep my instance for a month. I don't want to do that, so I'll choose pay-as-you-go. Database engine, you can see that for each of the 4 engines we offer, PostgreSQL, MariaDB, Microsoft SQL Server, and MySQL, we offer multiple database engine versions for all of those, which you can see here. In my case, I'm going to stick with MySQL, and I'll choose 5.7. There are 3 different editions. There's Basic, High Availability, and Enterprise. I'm going to choose a High Availability, and I will use a local SSD. So databases with local SSD have higher I/O throughput, higher performance, and also they allow more backup types. So if I were to choose standard SSD, I would only be allowed to make what is called a snapshot backup, where you make backups of the entire instance. Further, those backups cannot be downloaded. If I choose a local SSD type, which is only available for HA or Enterprise, then I'll be able to make snapshot backups of the entire instance, physical backups of the database, and also logical backups of a particular database or table. I then need to choose a zone. I'll choose Singapore Zone A, although I could easily place my database in A, B, or C. And I will choose a multi-zone deployment, meaning that the master and slave nodes are in different zones. This is the ideal scenario for robustness and availability because this type of database configuration can survive the failure of a single zone. I have to choose an instance type as well. Obviously, the price scales with the hardware selected. If I go up to 16 cores and 96 gigabytes of RAM, then I'm going to be paying quite a lot. It's $5 an hour. But if I choose a smaller type, like 4 vCPUs and 8 gigabytes of RAM, then I can have my instance for maybe 50 cents an hour instead. And there are both enterprise and entry-level categories for the CPU and memory configuration. I'll stick with entry-level. Capacity, it can be between 5 gigabytes and 2 terabytes. In my case, 5 gigabytes is plenty, so I'll scale my database down to 5. I then choose instance configuration, and I have to select a VPC and vSwitch for my instance. I have to select the parameters that will be used to configure the database engine, so I'm using MySQL's InnoDB, and I'll choose this high performance default template. My time zone is UTC plus 8 because I'm in China, and I will make table names case insensitive. And then I go click on next to confirm my order, confirm how many instances I want to buy, in this case just one, agree to the terms of service, and then I can click on pay now. And once I do that, that will purchase the instance and begin the setup process. So it will take a few minutes to configure the instance. So you can see here it says order complete. I can now close this tab, return to the RDS console, and once I refresh, I should see that my instance has entered the creating state. So here you are, you can see the instance is now being created. I now just need to wait for that process to finish. It can take between 2 and 5 minutes, so we'll fast forward through that. So we now have our RDS instance up and running. Let's go ahead and create an account and a database. So I'll click on Manage here to go to the management interface for this RDS instance. So you can see here an overview of whether or not there are any disaster recovery instances configured, any read-only instances. I can configure whitelists for access to the database. I can do a cross-zone migration, and I can even switch to subscription billing or delete the instance if I want to. Down here, if I click Change Specification, I can also upgrade or downgrade the instance as needed. What I'm going to do first is create a new account. So what I'm going to do is create an account for managing student records. So I'll call it Student Admin. Again, I just clicked on the Create Account button to bring this menu out from the right-hand side. I'll call the account Student Admin, and I'll make it a privileged account so it has full access to the RDS instance and all databases on it. And then I'll choose a password. Okay, and then I'll click OK, and that will create my new Student Admin account. Let's make a student database now as well. So I'll click on Databases here to go over to the database management page, and I'll click on Create Database. I'll call it Students. The font type, the encoding type will be UTF-8, and I'll click Create. And now I'll have a student records database as well. So now that I have my student database and my student database account set up, I need to insert some records into this database. So I can actually use DMS, Data Management Service, to do that. The DMS tool does a lot more than just permissions management. So if I click on Log On to DB, that will open a new tab that takes me over to the DMS Management Console. And you can see here, there's some information I need to plug in to be able to log into this database. I need the name of my database account, and I need the account password. I can check this box to remember the password so that the next time I log into DMS, I'll be connected directly. And then I need to test the connection. And this should fail because we haven't created a whitelist to allow access to the database. And when it does fail, DMS will send me it will pop up an informational dialog that tells me what IP address ranges I need to insert into the whitelist. So you can see here it says whitelist issues. Please add these IPs to the RDS instance whitelist. So I can copy those, go back to the console here, go up to basic information, and then there's this internal endpoint configuration here. I'll click on configure whitelist. That will take me to the whitelist configuration page. And before I create whitelists, I'll switch to the enhanced whitelist, which is a security enhanced whitelist configuration, and it's the default that we recommend. I'll click on confirm, and then I'll click to create a whitelist, and I'll call my whitelist DMS access. And I need to insert those two IP address ranges separated by a comma, and then I'll click add. And now I've created an internal endpoint for my database that's protected by a whitelist and allows traffic from these two IP address ranges used by DMS in the Singapore region. So I can now close this info dialog and retest my connection, which should now succeed. And you can see I connected successfully. So I can click log in to log into my database, my RDS instance. There we go. Let me close that password dialog. So here we are. This is the DMS console. And you can see I have on the left-hand side a list of all of my RDS instances. These are 5 instances that I'm not currently logged into. And here's the one that I am currently logged into. If I expand that tab, I can see all the databases that live on this RDS instance. Some of these are just default system databases that were created alongside the default MySQL database. My database here, students, the one I created, is the one we want to work with. So we can ignore these other database items and we'll focus on this students database. The first thing I want to do is create a table. So you'll see I actually have the ability to execute SQL statements right here from the web console, but I have no tables, so I can't really run any select queries, can I? So I need to create a table first. I'll do that by clicking on this little link. It says click here to start building the table. Let's make a table. I'll call it student table, and you can see I can set the database engine type, character set. I can insert validation rules. I can have row format requirements and so on. I'm going to leave all of that at the defaults, and I'll just create some new columns. And I actually have a CSV file with some fake student information in it, and so what I'm going to do is create columns that match that file. So just for reference, I've pulled up my CSV file, my students.csv, which contains the table of student information I'm going to insert into my database. Let's go ahead and use DMS to make a student table that has these columns. So I'll start with student name, click on new, we'll call that column student name. I need to choose a type. I'll choose a varchar type, a variable character, and we'll say student names can be up to 80 characters. Right? And then the next column is student average grade. So student average grade, and you do want these to match the CSV exactly. So student average grade, and that will be a double. Then we need, I believe, student gender. Let's double check. Yes, student gender, student age, and student ID. So student gender, student age, and student ID. That last one can be an integer, and it will be the primary key for the database, so it cannot be null. And then the student gender will again be a variable character type. This time it will be shorter, and the student age will be a big int. Great, so now if I want to actually go ahead and create this database, or excuse me, this database table, I can do that easily by clicking on modify, which will show the DDL statement that needs to be executed to create this table, and will even give some recommendations on how I should actually execute this. So for instance, it recommends that for some of these fields, I should add a note or a description. It also doesn't like some of the types. For instance, student average grade, it doesn't think should be a double. I'm going to leave it as a double anyway because that is the type that I want. And then I can click execute, which will directly execute that DDL statement and make my student table. In fact, if I wanted to, I can now right-click and go to Open Table and see a copy of all the content in the table. Right now, there's nothing. So I'll go ahead and close that. Let's close some of these unnecessary tabs here. Refresh. Oops. Let's do that again. We'll start from, some of these tabs are from databases I'm not logged into. So let's start over. This is the students database, and within that we have the student table. So if I want, I could do select all from students table. limit 20. And I should get nothing back because the table is currently empty. So we can also use DMS to import data, which is what we'll do right now. So let's try and put some data into this table. So I will go to Data Plans, and there's an option here, Data Import. I'll click on that, which will open a new tab, and I'll choose this Large Data Import option right here at the top. This will help me import large data sources like a large SQL script or CSV file. So I'll need to choose my database, so I'll choose Students. I need to choose File Encoding. I will not do Auto-Identify, I'll use UTF-8. My file type is CSV. I want to put my records into the student table, and I'll do that using insert statements. And now I have to upload a CSV file to insert student records from. I have one right here, students.csv. I'll choose that, and then we'll click Submit, and that will actually create a task. So I haven't actually imported anything yet. I am the DMS administrator right now, but DMS, again, is designed as a data management tool for multiple users. So normally what I would be doing as a RAM user would be submitting a task and waiting for the database administrator to approve it. That's why when I click Execute, what I end up with is a work order. This would normally need to be approved by a database administrator before this import could run. But in my case, it can run right away because I am the administrator. All I need to do is click on Execute Change, run immediately, confirm execution, and then the task will queue up and start. And if there weren't any problems, I should see the status as executed, and if I want, I can see some details. It looks like 100 rows of data were imported successfully, so that did work. So I can now close that tab, go back here, and rerun my select statement, and I can see there are now some entries in my table. So I have some fake names, some fake average grades, some fake genders. Everything worked. I do now have data loaded into my database. So now let's try to make a backup of our database. So let's go back to Backup and Restore in the RDS console. And you'll see I have the ability to restore from a previous backup, or to restore even an individual database or table, or to upload a bin log if I've got an offline bin log. I can do all that from here. If I want to make a new backup, I click on Backup Instance. So I have a few choices. I can make either a physical or logical backup, as I mentioned. Let's make a physical backup, and I'll click OK, and that will start the backup process. It might take a little while for that to run. If you're curious what's happening, you'll notice that refreshing doesn't cause the backup status to appear here. Nothing appears here until the backup is complete. The status shows up here. So if you click on this little icon, you'll see the status of the manual backup task. So let's click on that again. You can see it's 0%. If I click refresh one more time, click on that status, you can now see it's 25% complete. So let's just wait for that to finish. So after waiting a little while, the database backup is done. You can see that the full size of the physical backup, so all tables and schemas and all the data, is only about 5.8 megabytes because we really don't have a lot of data in our database. So if I wanted, I could then download this backup, so I have a local copy, or restore. Or if I wanted, I could restore an individual database or table from this backup. So let's try that actually. Let's go drop our table. So we'll go back to DMS, and I will choose drop table, and we'll drop the student table. Execute. Whoops, no more students. So you can see that we now have no tables. What am I going to do? How am I going to get my data back? So one way to do that would be restore individual database or table. So I can choose from my list of backups here. I can restore onto my current instance or onto a new temporary instance. I'll choose the current instance. And I'll say I want to restore the students table into the students database, and we'll click OK, and that should go ahead and bring the table back for us. So again, we may have to wait a minute for that. Let's try refreshing the page. You can see we have a task pending, and we are restoring that individual table. So now let's wait for that task to complete. So after refreshing, you can see the option to restore an individual table is missing. That's because we have to wait for the current restore to finish. You can see that we're at 17% now. Part of the reason this is taking so long is that in order to restore an individual table or database, the RDS system actually has to create a temporary RDS instance in the background, restore the entire physical backup onto that instance, and then port the table from that temporary instance onto our current RDS instance. Once all that is done, then the table should be restored. So let's wait a few more moments for that to finish. All right, so the Restore Individual Database or Table button is back, and the little red icon up here next to the task list has disappeared. That should indicate that our database table has been restored. So let's go back over to DMS and refresh the list of tables. And sure enough, there's a new table called Student Table Backup, actually, to indicate that we're recovering from a backup. Let's take a look at the content of that table. So I'll do select all from Student Table Backup, limit 10. And we'll execute that, and we'll see if the contents look right. So sure enough, this is our student data. We got it back. If I wanted, I could also have set up a RDS instance on my own and restored onto that. So I can restore an entire database that way with the Restore Database button. To do that, I actually have to create a brand new ECS instance first, and the restore happens on this new instance. If I restore an individual table or an individual database from an existing physical backup, then that creates a temporary instance in the background, which then is automatically deleted once the data is back on my original RDS instance here. Whereas if I choose this Restore Database option, I'm restoring the entire content of the RDS instance from the physical backup onto a new RDS, which is why it takes me over to the By page. And that's all for the Backup and Restore demo. So let's continue where we left off. We'll use the same RDS instance that we just used to test Backup and Restore, and now I want to try and create a read-only instance and also take a look at some of the monitoring and metrics and alerts that are available in the RDS console. So we'll start by going back to the basic info page. From here on the right-hand side, you can see our read-only instance count. Right now we have 0, so let's go ahead and change that. Let's create a read-only instance by clicking here. That's going to set up a clone of our existing RDS MySQL database that is read-only, and we'll then be able to create a read-write splitting endpoint that points to our new database cluster, such that when read requests come in, they can be routed to the read instance, and when write requests come in, they'll go directly to the master. And I'll go ahead and make this pay-as-you-go, and I'll deploy it in Zone A, the same zone as the master. We'll choose a small, 1 GB of RAM, 1 CPU core, and we'll make the capacity 5 GB just like our master instance. Then we'll move on to instance configuration. I need to choose a VPC and vSwitch. Again, I'll choose those to be the same as the master. And then we'll click on Confirm Order. From here, I need to set how many read-only instances I would like to create. You can see that I can create quite a few, although actually in practice there's a limit of, I believe, 15 or 16. In my case, I'm going to create just one. I'll agree to the terms of service, and then we can click on Pay Now. This should go ahead and create our read-only instance for us. So let's wait a minute for the purchase process to complete. Okay, it looks like the order has been successfully processed. So what's now going to happen is a new RDS database instance will be created. Our existing database will be migrated onto that new RDS instance, and then this read-only instance count should increment to 1. So you can see we now have 1 read-only instance, and in a moment we should see a migration task appear here. First, we have to wait for the instance to create. You can see if we go back to the instance list, I now have an ordinary database instance, an ordinary MySQL database instance, and a read-only instance. You can tell it's read-only because it has an orange and white R logo to the left of the RDS ID. So we need to wait a minute for that to finish creating. Once it's been successfully created, the contents of this RDS database will get cloned onto the read-only instance. So while we're waiting for that, let's take a look at some of the monitoring and metric information that's available for our primary RDS database. You can find that information here under Monitoring and Alerts. If I click on Monitoring and Alerts, I can see 1 hour, 1 day, 7 day, and 1 month worth of historical data, although in my case my instance was created today, so there's not very much to see. You can see I can see both CPU and memory utilization. I can see disk space utilization. I can see IOPS, so I can see IO operations taking place on the database, and I can see the total number of connections as well as inbound and outbound network traffic in kilobytes. All of that is available right here from the Monitoring and Alerts console. I can also monitor some specific qualities related to the database engine. like the number of queries per second, the size of the InnoDB buffer pool, and the InnoDB database engine read-write volume, as well as buffer pool read-write frequency and read-write fsync operations. I can even see temporary tables that have been created as my SQL statements are executing. So some of these temporary tables were probably created earlier when we were playing with our data in DMS. And you can see we have a full set of MySQL engine related metrics here. Let me scroll back up to the top. I can also monitor database deployments. So if I have more than a single instance, I can see the status of my other instances here. And I can, from the Alerts tab, set up alert rules that will cause an alarm, an email, or a message to be sent to me in the event that the status of the database changes. So all of that's available right here from Monitoring and Alerts. If I go back to the basic information page, we can see that the read-only instance is now being created. The task has started, the node has been created, and what we're going to do is make a backup of the existing RDS database and then restore that backup onto the new read-only instance. Once that's done, we'll be able to apply for a read-write splitting endpoint, which is a database endpoint that can automatically forward read requests to the read-only node and write requests to the master. So this is essentially a proxy service that will take incoming database requests from our application and send them to the appropriate database. Let's wait a minute for the creation process for our read-only instance to complete. So we've waited a while and the read-only instance has now been successfully created, and a backup of all the content from the master is now available on the read-only instance. So here's the read-only instance. You can see it's denoted by a white and orange R here. Our master here is indicated with this little split icon with two nodes. Let's go ahead and click on Manage next to the read-only instance. And actually, we should be able to log into the read-only instance the same way we do with the master. So by using DMS, it should have the same account and password configuration. So we should be able to log in as student admin with the same password as we did before. Let's test that connection and see if it works. So technically, during the creation process, the whitelist should have been transferred too. So you can see that we successfully connect without having to configure the whitelist. Let's go ahead and connect to our read-only instance and try running a select query on our table. So let's see what tables we have available to us. Excuse me, I first need to find the student database. There we go. And sure enough, the student backup database, student table backup from last time, should be available, and I can re-execute my previous SQL query. And sure enough, you can see all the records from the master database do also show up on the read-only instance. Now, in terms of monitoring and alerts, let's go take a look at that again. So monitoring and alerts, you can see here that we have resource monitoring functions at the hour, day, week, and month level, and we can monitor both high-level concepts, high-level resources like CPU and disk space and memory, but we can also monitor things like the status of the database engine, the status of deployments, if we're running more than one database. So you can see all that data here as well. And that is all for this demo. Okay, so for our very last demo of the day, let's go ahead and upgrade our instance configuration. So I'll go click on Manage for our master here, and I'll go ahead and upgrade him to a different instance specification. To do that, I just click on Change Specifications, and from there I'll be able to choose a larger instance class. So let's go ahead and do that. Let's upgrade to a C1.large, which has 8 CPU cores and 16 gigabytes of RAM. So this is much, much bigger than our previous instance. And we can also, if we want, scale the storage. So maybe scale that up to 10 gigabytes. And I can choose to switch immediately after data is migrated onto the new instance. And keep in mind that this is actually going to happen entirely in the background without any downtime because I have an HA instance. So when the master is offline during the upgrade, the slave can take over. So this whole thing should happen without any downtime. And I can click Pay Now, and that will begin the upgrade process. So we've now paid for our instance, and the upgrade process should get started. I'll go ahead and close this window, and we'll refresh, and just wait for the upgrade to complete. So after waiting a bit, we can see that the upgrade has finished. We're now in the running state here. Still pay as you go, but we now have 8 CPU cores and 16 gigabytes of RAM. So it all worked, and our storage has changed from 5 gigabytes to 10 gigabytes, and that was easy. It was all done entirely online without any intervention from us, except to initiate the upgrade in the first place. That's it for this demo. Thank you for joining.